This is the last section, and a lot of this I'm just going to go over briefly. Your textbook goes into a lot more detail. There is a few things I'll point out. We're going to be looking at disorders that occur in babies and how they're all genetic. So we're going to look at some dominant disorders first. Huntington's disease is a disease that does not attack somebody until they're in their 40s. So they don't know that they have it unless they had a parent and they knew what the parent had. But if they don't know they had it, they'll have children, they'll develop it, and then their children will develop it. It's a dominant trait, so the odds of it being passed down is very high. These are achondroplasia, the little people. It's a dominant disorder, and if two parents are both dwarfs, they will have a child that is a dwarf. Now we're going to look at something that's called sex-linked, which means it's on the X chromosome. It's not on the Y. And the reason for that is the Y chromosome is very, very small. It has only about 80 genes, whereas on the X chromosome there's about 300. So there's quite a few genes on the X chromosome that have no match on the Y. So sex-linked alleles, they're controlled by genes located on the sex chromosomes, X and the Y. They're usually carried on the X, and females will be carriers of it, but males will get it because they don't have a matching chromosome to fight it. And if you look over at the right on this picture, you will see they show sort of like a Punnett square, so you can see that the affected child is the male. Hemophilia, it's the bleeding disease. They now have a lot of treatments for this, but when I was a kid, they did not. And I knew a boy who had to go get blood transfusions all the time, and he ended up dying at around 11. But nowadays they have some wonderful treatments for hemophilia, but it is a genetic disease passed down to males. Red-green colorblindness. Now these are in color, and I recommend, if you're a male, to see if you can see the numbers. There's different numbers in each of the patterns, and that's how doctors test for it. But again, it's on the X chromosome, and there's nothing on the Y to counteract it. Now, codominant would mean both parents. Sickle cell anemia. That is a predominantly Black American disorder. It started in Africa, and apparently the people who are carriers for sickle cell, they have great ability to fight off malaria. So it was a evolutionary change to help them live longer, but now it is spreading through the population in the U.S. as there's more blending of people. And it causes a change in shape of the red blood cell so that they get sticky and they get trapped in the small blood vessels. Nondisjunction. Now, I haven't talked about this. This occurs during meiosis. And what happens is that when the sperm and egg are being formed, one chromosome goes into each of the 4 progeny. or offspring in meiosis. But what happens in this case is that one of the chromosomes didn't split off and it stayed with the partner, so that you might have a sperm cell that doesn't have that chromosome, or one that has 3 of that chromosome. Needless to say, this causes problems. One of these is called Klinefelter Syndrome, and these ones you all need to know. They're males, but they have an extra X, so their genotype is XXY. And they're sterile, and that's because of the extra X. They're often mentally retarded, reduced sperm production, enlarged breasts, small testes. Turner syndrome, they only get 1 sex chromosome. So it's usually demonstrated as an XO. So it's missing 1 chromosome. But because there's an X, and this person survives, they're female, they're short, but they're infertile. Down syndrome, it's called Trisomy 21. And I'm sure you guys know what this is, but there's a 3rd chromosome 21. So how do they look at these things? They use something called Karyotype Studies, and I have a picture of the karyotype on the next slide. That's where they match up the homologous chromosomes, so chromosome 1 with chromosome 1, chromosome 2 with chromosome 2, all the way down to the X and Y, or XX. And what they do is they take the chromosomes during metaphase, and they also make them go from smaller to larger. And that's how they determine which chromosome is which. If you look closely at this picture, you can see that they're banded. So there's a banding pattern on them, and they use that also to determine what chromosome is here. And if you look at this one, you can see that now these are homologous chromosomes, so there's 2 number 1s, 2 number 2s, 2 number 3s, and these represent 1 that came from the mom, 1 that came from the dad. Sperm and egg unite with 23 chromosomes in each, and you get 46. And that's what you got here, 46 chromosomes. So this is what we would, if we did a chromosome study on anybody here, we would find a similar karyotype. This is a male, and if it were XX, the X chromosome, if you look at it, is much larger than the Y. And for a female, you would have 2 large X chromosomes. We have these in the lab, and we'll be looking at them during this unit. This is the end. Hope you enjoyed it.